All right, well, hello. Here we go. So I'm going to start with this one. This is the one that we left off with that we didn't get to. And if we read through this, we've got two triangles, right? Right here and right here. And they said, which sequence of rigid motions will prove the triangle ABC is equal to RST? So I'm looking at choice one and it says a line reflection over the line y equals x. So I drew the line y equals x. Y equals x starts at the origin and then its slope is 1. So I went up 1 over 1, kept going up 1 over 1, and then down here I went down 1 left 1, down 1 left 1. So I drew that line. Okay? And so they basically want to know if this, when I reflect it in this line, in other words, if I folded my paper along this line, will this match onto that? You may or may not be able to see that. I'm not really great with these, to be completely honest with you. So I'm going to show you what I'm going to do. Okay, so I wrote down what A, B, and C are. So I just counted from the origin. I went to the left 1, and then that takes me up to 7. So there's my A. And I did the same thing with B and C. You should be taking notes on your paper when you do this, okay? Because that way you're showing work, and then that way you kind of understand what we're doing. If you have to pause me at any point in time, pause me so that you can take those notes. If you don't understand what I said, try to rewind me a little bit and rewatch it again. Maybe you have to do it a little bit more than one time. And if you still don't understand when I see you next time, we can always go over it, okay? All right, so anyway, so it says that we have to reflect in the line y equals x. So I don't know if you know the rule for the line, for reflection in the line y equals x. And it's pretty straightforward. Y equals x. It means, I'm just going to write the rule right there, yx. So basically what that means that you're going to do is you're going to take your y value and write it first. And then you're going to take your x value and you're going to write it second. So you're basically just flip-flopping. That's really all you're doing. So then I'm going to make this 7 and I'm going to make this -1. And then I'm going to do the same thing, 2 and then -3. And then I'm going to flip-flop here and write 1 and -1. Now again, I would like you to actually pay attention to me, and then you can again pause the video so that you can write everything down, okay? All right, so if you look, A prime should be 7, -1, B prime should be this, and C prime should be this. So I want to talk about that real quick because we have triangle A, B, C, and it should be going to triangle R, S, T. So one of my students taught me this thing that they learned, and I was like, oh, that's cool. So A is going to correspond with R, B is going to correspond with S, and C is going to correspond with T. So in other words, when I'm looking here at A prime is really R. When I'm looking at B prime is really S. And when I'm looking at C prime, that's really T. Okay, so I'm going to write those off to the side. So this is really going to be R. This is going to be S. Did I do that right? Yes. And this is T. Okay, if everything matches up, this is our answer choice. If it doesn't, then it's not. So is R 7, -1? So let's look at where R is. It is not. It's 1, 2, 3 over and then down 7, which is not what this says. Okay, so then we know that our answer is not choice 1, so you can cross that off. Okay, so now we're going to do choice 2. So I learned a pretty neat way to do this one. It's a rotation of 180 degrees, but it's not centered at the origin. It's centered at a different point. So when it's not centered at the origin, it's a different rule. Okay, so it's a 3-step rule, but it's not that bad. So what you're going to do is I rewrote A, B, and C down at the bottom here. I just want you to watch this first, and then again, you can take notes. All right, I'll tell you when to take notes. So what you're going to do is you're going to take that -1, which is the x value, and you're going to add this, you're going to subtract that x value from it. So I'm going to do -1. Then I'm going to take the y value, which is 7, and I'm going to subtract this y value from it. Okay, and that ends up giving me negative 2 comma 7. Follow? So I'm going to just kind of quickly repeat what I did. You don't need to take notes yet. I take this x value, subtract 1 from it. That's what I did here. Then I take this y value, subtract 0 from it. That's what I did here. That's what I got. Okay, that's the first step. All right, bear with me. Don't write anything down yet. Okay, so then the next rule that we're going to do is we're going to do our rotation of 180. And our rotation of 180 takes any point, right? Remember, a point is an x value, then a y value. And what we do is we negate the x value and we negate the y value. That's the rule for a rotation of 180 degrees, okay? So we negate this guy, we negate this guy. I'm going to do the same thing right here, okay? And again, you don't need to take notes yet. So rotate 180 degrees. So I'm going to negate the x value, and I'm going to negate the y value. Okay? All right. So again, just to back up, and I know I'm repeating myself, but so the rule is subtract 1 from this guy, subtract 0 from that guy. Then once you get your answer, you follow the 180 rule, which is negate both of your values. So I negated both of these values. This becomes positive, this becomes negative. All right, very last step. Let me put my pen back on. Now all we're going to do is we're going to take the answer that we got. So I'm going to take the 2, and all I'm going to do is I am going to now add these guys back to these guys. Remember, I subtracted them here in the beginning? Now I'm going to add them back. Okay, so I'm going to do 2 plus 1, and then I'm going to do negative 7 plus 0. Okay, so just to show you again, I took this, I added 1 to it, and then I took that negative 7 and I added 0 to it. I'm adding it back. So I subtracted it initially and now I add it back. And that's going to be my final answer. So just watch. I'm going to write it underneath. So that's 3 comma negative 7, right? And what that gives me is A prime. Okay, so A prime. Now remember, A prime is really R. So I'm going to just put and let's do a different color because why not? That's really R. Okay, now we're going to go up here and we're going to see if that's truly the case. Is R 3 comma negative 7? And let's just double check. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Bingo! Confetti. Answer is choice 2. Now, by the way, should you probably check them with these guys? Yeah, but usually, going through this whole process, you won't make a mistake. But again, what I would do, I'm just going to tell you real quick, is I would do negative 3 minus 1, 2 minus 0. When I get my answer, I rotate it 180 degrees, which basically means switch the signs. And then whatever I get, I just add 1 back and add 0 back. And that will give me my B prime. Okay? And there we go. All right, so the answer for choice 4, for number 4 rather, is choice 2. Okay, now before I start doing this question, I do have to say, I left off on the last question and didn't say, okay, now pause and go back and take notes. So if you didn't do that, just go back and take notes. All right, so now this one. So part A says draw and label parallelogram STUV. So boom, there it is. Hopefully that's not a big deal. Okay, now part B says graph and state the coordinates of parallelogram S prime, T prime, U prime, V prime as the image of the original after a translation of 4, negative 1. All right. Okay, so all a translation is doing is moving. we are going to take this picture and we are going to move it 4 to the right and then down 1. So every point here is getting shifted 4 to the right and then down 1. I don't like to do it from the graph. I just find sometimes kids just count wrong, make mistakes. So I like to do it this way. Okay, and again, same thing. I probably watch what I'm doing first, kind of like we did when we were tutoring. And then we can pause, go back, and you can take your notes, okay? So what I did was I just rewrote S, T, U, and V down here. We're translating 4, -1, which means we're going to add 4 to every x value, and then we're going to subtract 1 from every y value. And then I'm just going to write them right here. Because now, the reason why I'm doing that is if you look up here, not only do we have to graph it, but we have to state the coordinates. State the coordinates means we have to write them down. So I like to write them down and then plot them. Okay? All right. So you know what? We're going to color code this. So we're going to do this in blue. So I'm going to add 4 to everything here. So I'm going to start by doing that first. So if I add 4 to 3, I get 7. If I add 4 to 9, I get 13. If I add 4 to 7, I get 11. And if I add 4 to 1, I get 5. Then I'm going to subtract 1 from every y value. Okay, so I'm going to subtract 1 from here, 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 and here. Now remember, these are already negative. You can use your calculator. So I'm going to do -2 minus 1, -2 minus 1, -5 minus 1, -5 minus 1, just like that, okay? All right, so then if I subtract 1 from -2, that's going to give me -3. This will also be -3. Then -5 minus 1 is -6. And -5 minus 1 is obviously also -6. Okay, now I am going to graph those points. So if you want to pause me right now to write down the notes that I just wrote, go ahead and do that. And I am going to pop up the picture of S prime, T prime, U prime, V prime in a second. Okay, and there is your picture. I did it all in blue. Okay, so you can see all this did was it just kind of shifted, you know, to the left. I'm sorry, to the right. I don't know my left from my right. To the right a bit and down. Okay, so we graphed it. That's this. And we stated the coordinates. That's this right here. Okay, so now let's look at part C. Same thing, graph and state the coordinates. So same thing, I'm stating the coordinates of parallelogram S double prime, T double prime, U double prime, V double prime. After a reflection of, now let's read this carefully. It wants you to reflect this blue parallelogram, which are these points right here, okay? So a reflection of S prime, T prime, U prime, V prime over the x-axis. So we're going to reflect in the x-axis, reflect in the x-axis. Okay, so reflecting in the x-axis, I don't know if you remember that rule, but basically what we're going to do, remember we're taking all of these points, a reflection in the x-axis, we actually just change the y value to its opposite sign. So the x values are going to stay exactly the same. So let me color code that. So this is going to stay 7, 13, 11, and 5. And let me just pause my thought here. Don't take notes yet, just watch what I'm doing. Okay, so I didn't change anything here, but I'm going to change all of these. Reflection of the x-axis, we actually change the y, the opposite letter. Okay, so that's going to be a +3, a +3, a +6, and a +6. Now, if you want to pause and take those notes down, go ahead and do that. And then I'm going to pop up the video in a second. Not the video, the picture. Okay, and then you're just going to, from there, you're just going to plot these points. And, oops, back to my pointer, this is what I got. Okay, so it's this blue parallelogram, and it gets flipped over the x-axis. So remember, if I were to fold along this line, this will flip onto that. Okay, and you want to make sure that you label all of your coordinates. So like S prime, T prime, U prime, V prime. Don't just draw this pretty little parallelogram and not label each corner there. Okay, and let's read this again. Graph, we did. State the coordinates, we did. And we're done. Okay, so just again, if you need to pause the video, pause, take your notes, and then we'll move on to the next question. All right, here we go. Last one. So this is a proof. So obviously we start with the usual. You write down whatever givens they gave you, and then your reason is given. I'd like to look at the proof. So the proof is they're asking you to prove that AB, which is this line right here, or this segment really right here, is equal to ED. Okay, so when I see that, I'm like, AB is in this triangle and ED is in this triangle. So if they want you to prove this, I'm kind of in my brain working backwards. I know I have to prove those two triangles are equal first. Okay, so I hope that makes sense to you. So what I'm actually going to, I understand that they want me to prove AB is equal to ED, but what I actually first want to prove is triangle ABC is congruent to triangle E, doesn't really matter what order they go in, but EDC. Okay, so that's my goal. My goal is to prove these two triangles are equal. Now, I know that you know that there are different ways to prove triangles are equal because you did it with me yesterday. You told me them. You told me they were side, 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 angle, angle, and angle, angle, side. So we're going to use one of those four. And that is where this stuff comes into play. Okay? All right, so I'm going to take one given at a time. I'm going to start with angle 1 equals angle 2. So I'm going to go over here to my picture and I'm going to be like, all right, angle 1 equals angle 2. And then I'm going to say to myself, well, that stinks because neither of these angles are inside these two triangles that I actually want to try to prove are equal. However, hopefully you'll remember that this angle here and this little corner right here, and let me, I'm just going to go like that, and I'm going to go like that, okay? Do you notice that these two angles that I just marked are on a straight line? And these two angles here that I just marked are on a straight line, okay? And the double and this double are inside the triangles that I want to prove are equal. That's where my mind is going. So I got to back up. I have to figure out how to say this, but my goal is to get this angle equal to this one because those two angles are, these two are inside those triangles. All right, well, two angles that are on a straight line are called supplementary angles. So that's what I'm going to do. So I'm going to go like this, and I'm going to say angle 1 plus angle BAC equal 180 degrees. Okay, so this is angle BAC right here, BAC, this angle right here. So these two, bing boom, they add up to 180 degrees because they're on a straight line, and a straight line is 180 degrees. I'm going to say the same thing over here, just obviously, using different letters, but okay, so then I know angle 2 plus angle CED, they also equal 180 because they're on a straight line. Okay, the reason, definition of supplementary, that's a long word, right? Supplementary angles. Okay, supplementary angles are two angles that add up to 180 degrees because they're on a straight line. All right, step 3. Now, let's think about this. We already know these guys are equal, right? And certainly 180 is equal to 180. So that means these guys have to be equal. So let me just give you a for instance. If this was 40 degrees, this would have to be 140 because 40 plus 140 equals 180, right? So then if this is 40 degrees, this would also have to be 140, right? Okay, so what we do then is we can cut to the chase here and we can say angle BAC equals angle CED. Okay, so I'm going to back up. I want to kind of repeat. If these guys here are both the same, so let's just say 1 and 4, I'm sorry, 1 and 2 are both 140 degrees. If this is 140, this guy's got to be 40 because they're going to add up to 180. If this is 140 degrees, then this has got to be 40 because they're also going to add up to 180, which means these two have to be equal to each other. Okay, all right, how do we say that? I don't know how your teacher does it, but this is the way I do it. So, supplements of equal angles are equal. And that's really how you're supposed to write it. I don't know another way to write that. Okay, so again, we already know these are equal because that was in the given. And I know 180 is equal to 180. So that means these guys have to be equal to each other. That's what we said right here. And your reason is supplements of equal angles are equal. Okay, if you want to pause the video and write that down and digest all of that, go right ahead. All right, so now I have a set of angles inside my triangles, right? Boom and boom. Now, I always told my kids, if you see like two lines here and they intersect, or it kind of looks like a bow tie, these corner angles right here are vertical angles. They make a V, right? So those angles are automatically equal as well. So I'm going to color code that. So I know these angles are equal because they're vertical angles. So I'm going to just write that down. All right, so let me go to my step 4. So my step 4 is going to be angle BCA, that's the vertical angle on the left, is equal to angle ECD. That's the vertical angle on the right-hand side. And you can just say definition of vertical angles. All right, we're almost there. Okay, so look, we have an angle and another angle. We have an angle and another angle. So if we go over here and we look, we have two angles. So what that really means then is it's not going to be side, side, side because that doesn't have two angles in it. And it's not going to be side, angle, side because that doesn't have two angles in it. So we're down to either using angle, side, angle or angle, angle, side. Okay, now we have this last given here, AE bisects BD. Please be very careful. Kids mess this up a lot. AE is this line right here, and it is bisecting BD. Bisect, you and I talked about that, I think. It means to cut in half. But it is bisect, I'm going to sound like an English teacher here. It's bisecting BD. What the thing that comes after the word bisect is what's getting bisected. So BD is the thing that's getting cut in half, bisecting that. So BD is getting cut in half, which means C is the middle of BD, which then means, let me get out my little marker here, and that means that BC and CD are equal to each other. Oof, I shouldn't have chosen that color. I hope you can see that. Okay, I'm going to just make that super thick. Okay, all right, so that means BC and DC are equal to one another. Okay. All right, now I'm not sure if your teacher does this in two parts. I'm going to do it in two parts, but your teacher may not. Okay, so what I mean by this is first, I would start with this. I would say C is the, I'm going to abbreviate midpoint of BD. How do I know that? Definition of a bisector. Okay, so what a bisector does, it cuts something in half, and C would be that middle point. So we have to state that C is the midpoint of BD first. That's what I think. Your teacher may not do that, and if your teacher doesn't, totally okay. All right, then on my next step down, then I would say BC equals DC. And my reason would be definition of a midpoint. Definition of a midpoint. And I'm going to abbreviate that. Okay, so don't take notes yet, but just to show you. A bisector takes a line and cuts it in half, meaning C is in the middle. So this is saying C is in the middle by definition of a bisector. And now once you know C is the middle, you can now say that these two parts are equal to one another because C is the middle, aka definition of a midpoint. Okay, now if you want to stop, pause, and take notes, go right ahead. All right, we are almost done, I promise. Okay, so let's look at what we have. We have two angles and a side. And here we have two angles and a side. Is it angle, side, angle? Or is it angle, angle, side? Look at the order of the letters, it matters. And if you look, this side is not in between those two angles, okay? It would have to be here for the side to be in the middle of those two angles. So we're going to be using angle, angle, side. All right, so last step, well, second to last, you're gonna state those triangles are equal, and we're gonna say by angle, angle, side. Okay. Now you may ask yourself, well, that is not what they asked us to prove. This is true. But remember, once you know that two triangles are equal, all their leftover parts that don't have like little black curly things here or red curly things or, green slashes, all the leftover parts are also equal. And that's these guys. So I know since these triangles are equal to one another, then I know AB has to be equal to ED. Okay, so that's my very last step. So I'm going to write that down. AB equals ED. And that reason, I hope you learned this, is CPCTC. Okay, so again, if you've proven two triangles are equal, any leftover parts that we didn't, talk about in here are equal to one another. That's what CPCTC means. So you are never, ever, ever proving any parts by like side, 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 angle, side, or any of these. Okay, this is strictly used when we're proving triangles are equal. So any leftover parts have to be a CPCTC. Okay, I hope this helped. Bye.